Hi, I'm Kerry. I'm the host of Best of Us Investors. If you've been to my channel before, you know that my motivation for investing is to invest in things that are going to change the way I live. The second thing that I'm driven by is my tremendous desire to help and be a part of finding a cure for cancer. I support, that's what that jersey back there is. So my daughter died of cancer, my mother died of cancer. Hell, I'll probably die of cancer if we don't find a cure soon enough. And so that's a motivating force. Roughly 50% of my portfolio is invested in what I call the big six, and that's Amazon, Google, Apple, Microsoft, and Tesla and Facebook. Because I think they are the drivers of our economy. They are the companies that are going to change our world and at the same time have the money to change our world because of their position at this point. The second area that is even more focused is that of biotech. And I believe that through genome sequencing and genome therapies and genome editing, we're going to take most of the diseases that kill us out of our existence, and we're going to live into the future. And that's part of my hope, is that I'll live long enough that they'll take the cancer out of my body, and I'll have to get replacement parts. I'm going to live so long. So I invest in companies like CRISPR, Edits, Invate, Illumina, on the genome sequencing, Pacific Biosciences, and I'm always looking for another company. And the latest that I added to my holdings was one called Beam. And Beam is different than Editus and CRISPR and some of the others. And I wanted to learn more about it. So I've done some research, and that's what I want to share with you in this video, what Beam is all about and whether or not I think it's something that I want to. I already hold some, whether or not I want to add to it, and why, in fact, if I do, why I want to. So I'm going to introduce you through a video to John Evans. He's the CEO of Beam Therapeutics, and Beam Therapeutics is involved in base editing. And we've got to find out what's the difference between base editing and CRISPR editing, or are they the same? In fact, they have a lot in common. So that's what this video is about. And I'm going to share that with you and give you a source that you can learn more and make a good investment decision on your part. So let me first of all share with you that I'm not your financial advisor, and I'm here only for entertainment. And while I'm doing that and education, smash the like button, ring the bell, and subscribe. Be right back with you.
Best of Us Investors presents Kerry Griegmeyer.
Okay, what I did was I've done some research, and I came across a video that is put out by Gen News. And as best I can determine is Gen News is a company that does a lot of research into medical and genetics and such. It's hosted by Alex Philopoulos and Ken Davis, and they have a YouTube channel called Close to the Edge. And I want to basically show you some of the interview that they've had with John Evans of Beam Therapeutics. Now, Beam is a 4-year-old company, and John's been with them for about 3 years as the CEO, and they employ about 250 people, but they're approaching gene editing in a little different way. And so the first thing we want to do is come to an understanding of what it's all about and how it works. So the first question that Alex and Kevin asked was, what's the current state of gene editing? And John Evans responded to that. And so watch this.
Yeah, it's a great question. Actually, I would zoom out one click further. I mean, I actually think that we are really part of a general trend in medicine towards one-time therapies, right? So of course we have small molecules for 100 years. We've had protein therapeutics and biologics for 40 years. But increasingly there's this vision for a third class, which are these one-time curative therapies. It begins with gene therapy, right? Where we're just going to add some extra gene into the cell that may be missing. Maybe we do that with AAV, maybe we do it with lentivirus. And that's going to be, potentially helpful in a lot of different conditions. But then always there's been this idea that, wow, if we could actually edit the genome, if we could get down to the fundamental, bases of the genome that spell out the genes that are functional in life and manipulate them at that level, it might even be a more powerful and more durable effect. And so that's where gene editing comes from. That has been coming actually for a couple of decades now, but really it is true. We're kind of more of an exponential phase now. So you begin with meganucleases, zinc fingers, talons, and then, as you note, CRISPR. And with CRISPR, it sort of explodes. The reality is, what the improvements have been is just making it easier and easier to use and to sort of rapidly retarget genome editing systems to different spots in the genome. And that just increases the pace of change dramatically. And so it is true that CRISPR has taken this to a whole other level. And now, of course, within CRISPR, as you know, and we'll talk about, you have layers of innovation that are now happening there. So it really is I like to call it a sort of a Cambrian explosion of different innovative tools for manipulating the genome. And hopefully, the question we can ask in 10 or 15 years is what percentage of the therapeutics pie is dedicated to these kinds of one-time curative therapies? And I think it's going to be a lot more than it is today.
He used some terminology there that I really liked, and that is one-time therapeutics. And what that is basically saying is that the future is going to be such that if you determine that you have a disease in your body, that you will go in one visit or one therapy, they will take that disease out of your body. And that's what gene editing is all about. Now, I understand at some level CRISPR and how it goes in, and they use the term it cleaves, or they say scissors, goes in and cuts the genome and thus removes the variant or the mutation that is causing the disease. It's kind of like, you think about it, God made our bodies perfect, but we screwed them up as a result of our environment and the things that we take in and our breeding. So now what science is doing is coming in and finding a way to cure the mistakes that we and our ancestors have made. So now I understand the CRISPR and I understand the cleaving and the scissors, but what is base editing and how is it different? And this is John's answer to that question.
What is base editing and how does it differ from CRISPR-Cas9?
Yeah, great question. So gene editing, sort of traditionally, is solving one problem, which is a pretty profound problem, which is how do we target a single location in the genome? If you think about it, there are 4 different letters, A, G, C, and T, and every one of your cells has 3 billion of them in a row. Okay, and so in that some combination of those letters, we need to figure out how do I go to this gene and not all those other genes, right? And so what the gene editing tools, zinc fingers, talons, and CRISPR have solved is how do I target one address out of the genome? And it is a profound breakthrough. With CRISPR, you can do it simply by adding in a short programmable RNA element onto the CRISPR protein, and the CRISPR protein is always the same. And then if you swap out that little RNA cassette, you basically get a new medicine because now you're going to target a new spot. So the address changes. And so the reason why CRISPR suddenly exploded is the ease of use of that system. You can really rapidly retarget it to different places in the genome. So that's incredible. The drawback, I think, to this first generation of tools, which includes some of the CRISPR tools as well, is once you get to that address, the only thing that was possible was a cut. Okay, so the analogy often you may have seen is that of scissors for the genome. And so you get to a target site. Once that target site is recognized, it cleaves the DNA into 2 fragments. And then you're sort of up to the cell as to what happens next. So the cell will mostly not want that to happen. A double-stranded break is alarming to the cell. It's a genotoxic event. So it'll basically rush to put the pieces back together again. In doing so, it'll generally make mistakes, and so you'll get damage at the target site that is random insertions or deletions. So those are called indels. And so that will scramble a gene sequence, and you'll basically disrupt that gene. And so these tools are very good at knocking out gene function because you'll scramble that gene sequence. But using them to sort of reprogram genes or repair genes or make other sort of deliberate changes to gene sequences has been much more difficult. And generally pretty inefficient. And if you look at the field, generally the programs that have moved forward have been more like knockouts or deletions. And so that was the backdrop for base editing. And so basically David Liu felt originally that we needed to keep taking a harder look at this and find new ways to do this. And he had some very clever and pioneering scientists in his labs take up this project and make some really incredible innovations. So as I know you know, Alexis Komar in his group did the original C base editor. And later, Nicole Gaudelli, who's actually now at Beam, running our gene editing technologies group, took on the invention of the A base editor. So we can make two different kinds of single base changes now. And the basic trick is we use CRISPR to bind. It's the same address recognition and opening up of the DNA, but we've stopped its ability to cut. So we're no longer cleaving. We're not scissors anymore. And we take advantage of the fact that basically a short strand of DNA, when that binding event happens, is exposed as a single-stranded loop. And then the insight that Alexis and Nicole had was, let's use a deaminase, a chemical enzyme, that only recognizes single-stranded DNA, so it'll leave alone all of your double-stranded DNA, and is capable of recognizing one kind of base and just literally chemically modifying it from one to the other. So we do a C to T change with the C base editor. We do an A to G change with the A base editor. We don't need to have a double-stranded break. So once we let go, that change will be incorporated as a permanent edit to the cell. We don't need to change other bases around it. And so that coding sequence is preserved, and now you can basically have this highly efficient, chemistry-driven edit where we know the editing outcome, right? It's not random anymore. We know exactly that it will result. That allows us to think really therapeutically about what we're doing. And the last point I'll make is we're also not dependent on complicated repair pathways to process this edit. It's chemistry. Once you're in the cell, you'll go to the nucleus, search the genome, open the DNA, edit the base, and let go, and that edit will be permanent.
So with that in mind, what am I going to do about it? As I said, I already own a small amount of Beam. I already feel that I'm represented in the CRISPR end of it, but I'm feeling I need to add to my holdings in Beam. So my next question to all of this is, how far off is this? And John, later in the interview, and I'm going to put in the description the link to this interview because I think it's something you need to see. And it's about a 54-minute interview. And if you're interested in this space and you're willing to put in the work, you need to see this video. He's basically saying they'll be in clinic in the second half of this year. They're actually, in fact, building a manufacturing facility in North Carolina. I think he said it was about 100,000 square feet facility where they're going to manufacture the therapies, the drugs, the chemistry, I guess that's the right way to put it, that base editing is going to make available. And he sees that being done in 2023. The other thing he talks very extensively in the latter part of this interview is the collaboration that they are entering. They're recognizing that they might have the delivery mechanism through base editing, but other people will provide then the therapies or the chemicals that will help take out other diseases. As John says, they can't be everything to everybody. So they have already created a collaboration with Prime Medical and another one by the name of Verba. And he says later in this interview that they're focusing on sickle cell anemia because number one, there is a lot of it. And secondly, it is very definitive in its location and how to get rid of it. So, but I also know that CRISPR is focusing on that and EDIT is focusing on that. So it comes down to my way of thinking. I said this in a meeting every Monday and Friday. I meet with my tribe. That's the people who come to our Discord. And I made the statement that I look at this as a horse race, and that every horse is going to finish the race. One is going to win, another one is going to place, and another one's going to show. I want to bet on all the horses. I want to cover all the bases so that when this technology, and as John says, it's coming fast, and it's been expedited as a result of the coronavirus. I want to own them all. I want to have something of CRISPR. I want to have something of Editas. I want to have something of Illumina, and I want to have something of Beam. And there are others. He mentions, as I said, Prime Therapeutics and Verb, V-E-R-B, I believe it is spelled. So go to this channel. Go to the channel of Gene News, and I'd suggest you subscribe to him if this is an area you want to specialize in and become knowledgeable. Because, again, I look at it and say, I can't compete with the big guys. They have research departments. They have a lot of analysts that I don't have access to. But if I can gain a little bit more knowledge than 90% of the rest of the world, I've got an advantage. And that's what I'm trying to do in my portfolio. And that's what I would encourage you to do in your portfolio. If you have an area that interests you, that you have a passion about, specialize in it and learn more about it. And that's what we're trying to do at Best of Us Investors Tribe. We're trying to put together people with a common interest, but maybe more specific interests, and then learning from each other. As I said, I'm specializing in big data, and that's easy. That's Amazon, Google, Apple, Microsoft, Facebook, and Tesla. That's easy. They've got the knowledge, they've got the money. They're going to take us in that direction. But genome editing, genome therapy, and delivery of a better healthcare system is in its infancy. And I shouldn't say that, because they've actually been working on this for about 15 years now. But as a result of the coronavirus, this thing is just accelerating. So I'd suggest you subscribe to Gene News, or I guess the site is Close to the Edge, and the link is in the description. And learn more about this, and then make a good investment decision. So that's my take. I'm going to be buying more of the Beam, because again, I think they've taken CRISPR a step further, or you might say in a different direction. And I want to own some of all of it. Okay, I'll be talking to you again tomorrow.